This will be a VXLAN primer and basics video, kind of geared towards an introductory level of what VXLAN is. Maybe for someone who doesn't know, this video is going to be kind of what I wish I had when I started learning it, to help me understand the concepts, some of the configuration and how it works and what it maps to, some of the different functions. So we're going to also lab up a flood and learn example. I'll talk about what flood and learn is versus using BGP. But in some subsequent videos, I want to also take the flood and learn lab further, adding BGP to it, kind of showing what advantages that has. But for this one, this is going to be concepts, and we're going to build the flood and learn example to see how it works. And, you know, I guess high level, what VXLAN is doing differently than maybe a traditional particular data center will be the context of what I'll be looking in here. But so traditionally, if these nexuses, say the Nexus 1 and Nexus 2 were your core switches, maybe they were 6500 or something, you know, in the old days we just used the spanning tree. One of these links would be blocked onto each of the downstream devices, which worked. And maybe you'd set one of these as your spanning tree root, and then this would be a secondary in case the primary failed. It worked, but you have this issue of blocking the links. So that's traditional spanning tree. Then we moved on. The next major one would be VPC, virtual port channel, where we took the cores and we cabled them up in a specific way where they would look like it was a single device to every downstream switch. So in other words, Nexus 3 thought it was connected to one switch, even though it was connected to two. So we were able to port channel these together. And we have no blocked links in this case. And the Nexuses 1 and 2 would synchronize their ARP tables and their MAC tables over these links here. Spanning tree still runs, but this, you know, trickery here tells switch 3, 4, and 5 that it's the same switch, even though it's not. But the intelligence here is smart enough to not loop it. And so we would still make Nexus 1 and 2 the spanning tree root here. Now VXLAN is the next, I guess, major iteration of technology where we don't even, so traditionally these were all layer 2 links, all of these right here, and we would trunk up here. But in VXLAN, these are moved to layer 3 links. And so yeah, that might present, you know, some obvious problems, like how does PC1 and PC3 talk to each other if they cannot trunk to each other? And so VXLAN, what it's going to do, it's going to take a frame, say from PC1, when it gets up to here, and it's going to put a new header on it, and then it's going to be routed to PC4 or Nexus 4 based on this new header here. And so this is going to be similar to maybe if you write a letter and then you send it in the mail to somebody. You take a letter, stick it on in an envelope, and then you write an address on the envelope, and then you give it to the postman. He gives it to another postman or to the post office, and it could go through 100 people. They're not going to open the envelope. They're just going to look at the address, and then it's going to get to the final destination where the last person who it's destined to, they're the ones that opens the address. So this idea of sticking something in something and then making decisions on that outer piece, like the envelope, is what we're going to call encapsulation. And we'll see how that works in detail a little more. So that's kind of the idea. So some questions kind of arise, like how does Nexus 3, for example, how does it know where anything else is? How does it know where PC3 is? Because if these were layer 2, we would just simply broadcast. It would make it down here, and then the Nexus 4 would learn the MAC address over the data plane like a switch normally does, just listens for the incoming ports and then adds that MAC address entry to its table. And So this is going to change a little bit when we have, these are all layer 3 links. And there's two major ways that these switches can learn about hosts. The first one, which what we'll lab up in this video, is called flood and learn. And essentially it's going to learn it over the data plane. So Nexus 3 is going to encapsulate, like we looked at, some frame from PC1, say, and then it's going to send it to 1 and then 4, or it could send it to 2 and then 4. It doesn't really matter how it gets there. But it gets to 4. 4 is going to look at the packet, understand where it came from, and then add an entry there. We'll look and we'll see more of this in detail. That's the first major way. That's kind of called flood and learn, because it floods it, and then based on that flooding, it learns it. So it's kind of an intuitive name. The second way is using BGP, and we'll come back to that later and look at more of that later. So let's kind of look at the lab, I think, and start configuring this. So these are all Nexus 9000 V switches that I've got labbed and cabled up. I have the physical diagram here I might need to reference, but I don't have any configuration yet, just so we could show, the complete steps. All I do have are the IP addresses on the interface, because that'd be boring to watch me do all that. But the IP addressing these are all point-to-point links. I think I use this, everything's a /24 just for simplicity. But these could be a /30, 31 to preserve IPs. But in this example, the physical interfaces, I use 10.255. And then I use the link between them. So this link would be 13. And this would be 13.1. This side would be 13.3. This link right here, for example, it would be 10.255.15. So Nexus between 1 and 5. This side would be .1. This side would be .5. So here I'll show you what I mean. So there's 10. So this is the link between Nexus 1 and 3. That's between 1 and 4. And that's between 1 and 5. The only other thing I did was put a loopback on all of them, where it's 150.1. This would be 3.3, 1.1, 4.4. So here's a 1.1. And for this lab, we're just going to focus on this kind of the left half. So I really don't need this right now. Maybe I'll make this bigger to see it. Okay. So I think the first thing I want to do is bounce some of these interfaces. This lab here is flaky a little bit. You can see the protocol is down, link is down. That's just a problem with the lab. Okay, it should be up now. Yep. All right. So the first thing we want to do is configure some kind of IGP in order to establish reachability between these devices, because right now they don't really know how to get to each other. So Nexus 3, it doesn't know how to get to, say, the loopback of 4. It has no idea. And when we do VXLAN, we're going to encapsulate the packets with the source and destination of our loopback. So in other words, Nexus 3, if it's sending to 4, it's going to destine it to 4's loopback, and it's going to put a source of its own loopback. So it would look like, I'm going to 151.44 from 151.33. So in other words, you got to have loopback connectivity. In our case, we're using loopback 0. That must be reachable from every place in the network. So we are going to use OSPF to do that. We want to support kind of the overlay. And what I mean by overlay, let me show this here. So let's look at like how a packet is going to work here when everything's working with flood and learn. So PC1 is going to generate some kind of frame that gets sent to Nexus 3 like normal. When Nexus 3 gets it, it's going to do a lookup. It's going to realize it needs to go to Nexus 4. And so when it builds the encapsulation, or we could say sticks it in the envelope, it's going to add a VXLAN header, a UDP header, and an IP header. Now notice the IP header is sourced from Nexus 3, destined to Nexus 4. So it's a unicast under a normal circumstance. And we'll talk about when that'll be different. Now when Nexus 3 routes it to 4, it's going to send it to either 1 or 2, which we're calling that the underlay. And the Nexus 1 and 2 is going to route the packets based on the destination IP. And so that's how this original frame gets hidden. It's not accessed to be used for any routing decisions. It's in the envelope, kind of. So when this gets routed, it goes up, back down. When Nexus 4 gets it, it's going to realize, yep, this is to me, destination. That's me. I'm going to take that off. Take that IP header off. I don't need that. I'm going to take the UDP header off. Don't need that. I'm going to look in this little VXLAN header for a number, because that number is going to tell me what VLAN this goes to. Once I have that, I pop the VXLAN header off, take the original frame, and then I pass it into that VLAN, specifically into that host that it goes to. And that's kind of the high-level idea of how it works. So you see the encapsulation hiding everything until it gets to where it needs to go, then it unhides it. And so what we want to do now is configure the Nexus 1, 2, 3, 4, and 5 with, I'm going to use OSPF, because we want to support back to how when it's routing here, everything in this network needs to know how to get to these loopbacks, because that's where the in-cap and decap is happening. So that's the purpose of building an IGP, is we've got to provide reachability to these loopbacks. So let's do that right now. We'll configure OSPF on 1, 2, 3, 4, and 5 on these Nexuses, test the loopback 0 connectivity, and then we'll move on to something else. So the first thing on the Nexus we want to do is turn the feature on. It's not turned on by default. Okay, and it's going to be on everywhere. And now we got to turn this on an interface by interface basis. So let's go down to this diagram here. So we can see we need it on 1, 2, and 3 on Nexus 1 and 2. So 1 through 3. And I think I need to let's create the process first. So router OSPF, and I'll call it OSPF in capital, so it's kind of obvious to what it is. All right, now we'll go back to that interface, put this router in the put this interface in the OSPF domain, and then area 0. We're just going to use one flat area. It's going to be simple. One other thing I'll do just for fun is put the network type as point to point. You don't have to do this, but it just makes the OSPF database a little more lean, getting rid of the type 2 LSAs. It's not important. You don't have to do that, but it's a little optimization. Okay. And we're also going to put loopback 0 into OSPF, which is going to be the really important, just as an important step. Okay. Now what I want to do is take this exact configuration and put it on Nexus 2. So I'm going to show my history. I'm just going to copy and paste. So I'm putting these first 3 interfaces in and loopback 0. Okay. Let me check these interfaces. Okay, they're all up. Good. So 1 and 2 are done. Let's go to 3. These only have 2 interfaces here. And then put the loopback 0 into OSPF. Now show CLI history last 7. taking this and I'm going to paste it on 4 and 5 because they're the same interfaces. A lot of this configuration is templatable, which is good. And 5. And that should be all we need to establish the OSPF adjacencies and reachability between all the loopbacks. So let's just do a quick spot test. So if I were to ping 150.111 source interface loopback 0, I'm just going to cycle through these. Okay, we're getting replies from everything. That looks good. I'll just do one more. I'll just do 5.5. Okay, just cycle through them. So we're getting replies. So now we should be able to support, the overlay network. So the traffic coming from these PCs, we should be able to support that at least a little bit now. Now the next configuration step, all we've got on there is IP addresses and OSPF. The next thing we want to do is put multicast on there. The reason we want multicast is it helps us emulate broadcast traffic, or what's they call BUM traffic. So broadcasts, unknown, unicast, and multicast. So it's typically traffic that has, not a single destination, but a multiple destination, like a broadcast packet in Ethernet. Because traditionally PC1 would ARP, it would, be layer 2 up here traditionally, and then it would go down and everywhere would see it. But here it doesn't work like that because ARPs are not going to really make it past the switch that the device is connected to. So we need to emulate broadcast. It's essentially what we're going to do with multicast is we're going to set multicast up to where it emulates the broadcast, because if PC1 wants to talk to PC3, they're in the same VLAN. We need PC3 to be able to hear an ARP, or PC1 to be able to hear an ARP. And the way we're going to do that is to set multicast up. So Nexus 3 will take the original frame, encapsulate it, but this time it'll send it to the multicast tree, which will be Nexus 1 and 2. It'll be the root. It will send it down the multicast tree to all switches that are part of that VLAN. And then once it gets down there, it'll get decapsulated and sent to all the ports. And sounds unclear. Well, it'll be clear here in a minute. So let's configure multicast, and then I'll show you to clear it up, because it sounds confusing until you see what it does. So the first thing we need to do, like we did a while ago, is turn multicast on, and in this case it's going to be PIM here, feature PIM. And then I'm going to make Nexus 1 and Nexus 2 the rendezvous points. We're going to use Anycast to do this. Now this is not VXLAN configuration. This is just multicast configuration here. So it's nothing really VXLAN specific here. And so I'm going to make 1 and 2. I'm going to have them back each other up, put them in an RP set. But the first thing I think I want to do is on all these devices, tell it what the rendezvous point address is. And so IP PIM, RP address. I'm sort of going to make this up 1122. And it's going to be for everything. Group list 224.0.0.0/4. That's the whole range of multicast. So what I'm doing is putting a static entry on everything, all of the switches, to tell it where the rendezvous point is. Now that IP doesn't exist right now, but it's going to right now. So I'm going to go to Nexus 1 and 2. I'm going to make a new loopback, and I'm going to put that IP address on it. So I'll just make this loopback 1. Loopback 1. /32. It's important to put it in area, or put it in OSPF, because these Nexuses need to know how to get to it. And let's say IP PIM Anycast RP. This is making the RP set. So the first number is the IP address that Nexus 1 and 2 share. And the second number is their unique loopback. So it tells the routers who's participating in this with me. And then the last step for this is to enable PIM on the interfaces. Again, this is multicast configuration, not really VXLAN specific configuration. And it's IP PIM sparse mode. We also want to put this on the loopbacks. IP PIM sparse mode. Okay. I want to do the exact same thing on Nexus 2. So I'm just going to look at my history. I need to go back more. Okay. Okay, I think I was here. So I'm going to put the loopback 1 on here, put it in OSPF. Put it in the RP set, and then turn PIM on all the interfaces. Okay. And last, I just need to turn PIM on E1 and E2 on Nexus 3, 4, and 5. And the loopback 0. So show CLI history. Copy and paste this on 4 and 5 because it's exactly the same. Now I believe if I did that all right, we should have a multicast configuration done. Let's maybe a quick show IP PIM RP. And so 1 and 2 is going to show the RP set. So here it is. Here's my members, me and 2. Here's the other one, same thing. 3, 4, and 5 is just going to say, I know the rendezvous point is that. And it's for all of my ranges, IP ranges in the multicast range. Okay. All right. So let me try to be a little more clear on what this is accomplishing. Let me show a little animation here. So this is so we've configured Nexus 1 and 2 to be the blue rendezvous points in multicast. And so the way this will help us sort of emulate broadcasting. So let's say we have a frame come from PC1. Let's say it's an ARP. Say maybe we're trying to talk to PC3. So the ARP is going to go up to Nexus 3. Nexus 3 is going to do a lookup, and it's not going to have the MAC address for PC3. And so that's the problem with the layer 3 links, is when we ARP, we can't get there. We have to make it get there somehow. And so what we're going to do is we're going to send it to a multicast tree, which is going to send it down everywhere to get there. So you can probably imagine, is this much better than just leaving it how it was with layer 2 links? Because it's still flooding. And flood and learn, that's just how it works. It will get smarter and eliminate a lot of this at maybe a next step when we put BGP. But for now, the flood and learn, it does flood everywhere. So in other words, so PC1 puts the frame up to Nexus 3, does a lookup, it's not there. It doesn't know how to get there. So what it does, it sticks the VXLAN header on there again, UDP header again, IP header again, but what you'll notice is different here is the destination. It's going to a multicast group, not Nexus 4. It'll get to Nexus 4, but it'll get there through the multicast tree, not a unicast packet. So what'll happen, it'll get routed and it'll get sent to 4, and it would get sent to other switches as well. but it would, in just my lab is small here a little bit. So it does get to 4 based on the multicast tree. Once it gets there, 4 takes off the IP header, takes off the UDP header, looks at the VXLAN header to see, okay, which VLAN does this belong to, takes the VXLAN header off, and then it'll send that down to every PC in the VLAN, which is just this one PC in this case. So the important thing with what we're trying to accomplish here is the multicast. We're trying to give that availability. Okay, hopefully that's a little clear. So the idea is we're emulating broadcasts by using multicast. And hopefully there's no possibility for a loop, because once it goes down the multicast tree, it's done. Whereas a broadcast kind of has the potential to loop. Okay, so now we have, now that we have the multicast done, the last thing we'll do in this video is put the actual fun part, the VXLAN part, on, and then see how it works. And then we'll establish reachability between some PCs. So the first thing we want to do is create the VLANs to begin with. So on Nexus 3, let's go back up here. I'm going to put PC1 and PC3 in VLAN 10. And then I'm going to put PC2 and 4 in 20. PC5, we'll mess with that later. You can see that's in a different VLAN. These are all /24s. So that's 10.1.1. So the idea with these colors is these represent customers or tenants. So in other words, yellow or the orange would be one customer or one tenant, and blue would be a different tenant. So what we want is all the orange to talk to each other, and we want all the blue to talk to each other, but we don't want orange to talk to blue or blue to talk to orange. So VXLAN has this multi-tenancy within it to separate customers. So you could even have customers with overlapping IP addresses, and we can distinguish them. But this PC5 is going to route to 3 and 1, but we're going to come to routing later. So we're just focusing on 1, 3 right now, 2 and 4 right now. So let's get into some of the VXLAN configuration. And there's not too much of it here. So Nexus 3, let's create VLAN 10. That'll be sort of tenant 1. And then we're going to associate this VLAN with what's kind of called a VNI or VNID, or the configuration is VN segment. And I need to turn the feature on again here. I don't think I did that. So what I need on here is feature NV overlay and feature VN segment based. Feature VN segment VLAN based. So I wanted to take these and put them on 4 and 5. Because these are sort of the leaf switches on our topology. 4 and 5. Now that'll give me the syntax. That unlocked the syntax for me. So if I go back to VN and type VN segment, now it's letting me actually type that. Then I'm going to make a value here, and you can see the range. I'm just going to do 110. That way, I just prefix it with 100. That way we can kind of see what it is just by looking at it. That's going to be VLAN 10. On Nexus 3, I'm also going to create VLAN 20. And then I'm going to give it 120. So what I'm giving it here, let's look at it. Show run VLAN. I'm giving it this field is going to go in the VXLAN header. As it's getting passed through the network, this tells the switches what VLAN this should go into. So when Nexus 3 gets a source frame, gonna look and say, what VLAN does this come from? I need to know the VN segment. So in this case, it's gonna say, yep, that's from VLAN 10, but what I'm gonna actually put in the VXLAN header is this number. And then when it gets to 4 is gonna look at that 110, and it's gonna say, okay, what VLAN is that mapped to? And then that's how it does that association. That's how it knows where to put it. So in this case, I want them to be the same, just for kind of common sense, making sense of everything. I'm just going to do that, make them the same. And so now they agree on the VLAN and the VNI number. And to be a little more clear, here's sort of a diagram here of the encapsulation. The original layer 2 frame is what PC1 would send, and then Nexus 3 would stick a VXLAN header on it. Now if we look at the details of that header, follow this little arrow, there's a VNID. That's going to be this number. That's what's going to be put on for every frame to tell it kind of what VNI or VLAN, however you want to think of it, what is going to be part of. Then it sticks on a UDP header. That's a normal UDP header. That's a normal IP header, and that's the normal MAC header. That's the one that gets swapped out from every link. But the routing decisions are made on the IP header until it gets to the final destination, which then takes it off, looks and see what VLAN it belongs to, and then sends it out that VLAN. So now that we've got the VLANs and the VNI mapped, notice we only had to do that on 3 and 4. You only need to do that where the hosts exist. I did not need to do it on 1, did not need to do it on 2, didn't need to do it on 5. So you don't need to have the configuration everywhere, just where it's needed in this case. So the next step is we're going to make the interface that does the encapsulation and decapsulation. And so again, we only need to do this on the leafs where we have a VLAN that's participating in it. So here we want to make interface. This is called NVE1. It's just always going to be called this. I don't think you can even, that's the only option. And then, like I said before, the tunnel is going to be from and to a loopback. So that means we need to put source interface loopback 0. And then we need to specify what VNIs can be encapsulated and decapsulated. So member VNI 110. And then here's where we map it to a multicast group. And so what I was doing, MCAS group, and I'm just using something in the range, just made this one up, 10. And now let's do the same thing for VLAN 20, and then we'll back up and look at the configuration. No shut, show run, NVE1. So let's look at what we just made. We made the sort of the logical interface that these packets are going to be going out of and coming into. And so when we have something for VLAN 10, and if we don't know where it goes, we put it in this multicast group, send it to Nexus 1, which is going to send it down the tree, and it's going to get everywhere it needs to go. But it's just going to do it in a multicast fashion rather than a unicast fashion. And so for VLAN 20, it's going to be mapped to a different multicast group, but it's going to be doing the same thing. Now this we need to also have on, or I'm going to put it on 4 because 4 has hosts that we want to talk to. It's going to be the exact same configuration. All right. And we can add, just for, so we don't have to come back and do it later, I'm going to add PC5 on this tunnel here. So in other words, I'm going to say member, actually first I'm going to create the VLAN 11, VN segment 111, and then interface NVE1, member VNI 111 MCAS group 228.0.0. I'll just use 11. So what we have here, the difference on this switch is it's including VLAN 11 because it exists here. VLAN 11 doesn't exist on Nexus 3, so I don't need to put it there. And this should be all that's needed to have this work. So we should have, let me make sure all the interfaces are up in this lab here. Okay, and I'm gonna power on PC1 here and PC3. Actually, but let me think before I do, because when I power it on, it's gonna start ARPing. Trying to think of, I might want to catch something here. What I'm gonna do is start a capture on these interfaces right here on Nexus 3. That way we can kind of see what it's getting. So I'm gonna start a capture on 1.1 and 1.2. And let's look at it so we can understand how it's, make sure it's working like we think it is. So this is the E11 on the left side. And let me do one on E12, which will be this one here. Okay. So I'm gonna turn computer 1, PC1 on, and let me just do that. Okay, start. Let me open it up here. So see, it's checking for duplicate. So that sends an ARP out when it does that. Now I don't have PC3 on, but we probably should see that ARP on one of these interfaces. See, we can see some OSPF. Some multicast. Let's look at so one thing that I did not do yet is actually put the PC in VLAN 10. I think I made VLAN 10, but let's go to Nexus 3 and interface E13 is switch port access VLAN 10, and then spanning tree port type edge port. That's like a port fast configuration. I need to do the same thing on Nexus 4. Interface E13, switch port access VLAN 10, switch port spanning tree port type edge. All right, now that makes more sense. All right, so I'm gonna, PC1's already on. I'm gonna turn PC3 on now, because that should do an ARP as well when it comes on. Okay, so there's checking for duplicates. It should have done an ARP. And so there's OSPF, ICMP, something on IPv6. And here's the ARP. Okay, so let's look at that a little bit bigger. So if we look at it, there's the ARP, there's the Ethernet. So this would be the original frame would be right here. And then here's the VXLAN header that gets added to it. There's the UDP header, there's the IP header. Now notice it's from Nexus 4, but it's going to the multicast group. That's because, go back to the diagram, when PC3 was turned on, it did an ARP. It went to Nexus 4. Nexus 4 didn't know where PC1 was, so it sent it to the multicast tree. Now let's see if Nexus 3, let's see if it learned it when it came down the multicast tree. So show MAC address. And so I believe, so let's look at the show IP, look at the MAC address. It's 680B, that's the MAC address for PC3. If we go to Nexus 3, we can see it. It learned it. So it learned it when PC3 came on. It did the ARP, it was encapsulated, as we saw right here. It was encapsulated to the multicast address. It went up to either 1 or 2, and then it came down to 3. 3 took it out of VXLAN encapsulation and then sent it down to PC1. And when it took it out, it learned to where it's at. Now it looks a little different because I did, show MAC address table. And here, normally it's going to show you a physical port that it's located out. But in this case, it's showing me it's located out this logical port. And then that's where it's going to build the frame 2. So any subsequent traffic can go unicast, not multicast. So that's what the benefit. Once it's learned via flooding, it doesn't keep using multicast. It switches over to unicast. So let's go to PC1. Let's see if we can ping it. We should be able to. 20. Okay, we can. So now let's look at the captures here. Here's some of the pings. Let me just open one of these and bring it over. And now look at the source and destination. They're unicast packets, it used multicast initially to flood it, then it learned it, then it switches to unicast, which is more efficient. So this is what I mean, encapsulation from and to the loopback interfaces. Okay. So, I think that showed really what I wanted to show. Again, just a final, packet walk of it. PC1 would send an ARP to PC3. Nexus 3 does a lookup. If it does not know where it's at, it sends it, VXLAN encapsulates it, sends it to the multicast tree, which would send it to 1 or 2. 1 or 2 would send it down to every switch that is joined to that multicast group. And so 4 would get it. Now, how do you know if it's joined to a multicast group? You look at this NVE interface. So show around interface, NVE1. When you configure a switch, right here, whenever you type that in, it goes and it joins that tree. So that's how Nexus 1 and 2, the rendezvous points, that's how they know where to send it, is that who's joined to this multicast group, who has this NVE interface. And so PC1 ARPs, sends it to 3. 3 doesn't know where it's at, sends it to the multicast rendezvous point, which sends it down to every switch, including this one. 4 receives it because it's joined to that tree, looks at the VNI, what VLAN does this go to, takes the rest of the VXLAN headers, throws it away, and then sends it down every port in that VLAN, which in this case is just 3. When it does that, 4 at the same time, 4 learned where 1 was over this flooding here, because it's able just to simply look where this come from. Oh, it came from 3, and then 4 put it in its table. So show MAC address. So it knows 6809, which is PC1. Yeah, PC1. It knows 6809 is, if I want to get there, I send it out this logical interface to that IP address, which is the loopback of 3. So it learned this via flooding. That's why it's called flood and learn. So it uses the multicast to flood it. As it does that, it learns it, and then subsequent traffic can take a unicast. So that's sort of the basics of how flood and learn works. I think what I want to do next is add BGP to it. When we add BGP to it, it's going to really eliminate a lot of this flooding, because the issue is, the flooding is, the Nexus has to take the packets, make copies of them and send them down. So we can eliminate a lot of that with using BGP, and I'll go over that next, but you still would want multicast configured, because if BGP doesn't work, or I mean, like if there's a certain case, maybe a silent host where something's not working, it can fall back to this flooding. So this flood and learn is kind of the base initial part of VXLAN on which we'll build more to get better functionality out of it. So hopefully that was helpful at sort of a basic beginner VXLAN configuration, an example.